All right, ladies and gentlemen, today we're going to talk about finding the length of an arc. So it's very important, first of all, that we know that the length of an arc is what is called an unbroken part of the circle. So it's a piece of the circumference. So if you can think of the circle as a pizza, the arc length or arc is a piece of the crust. Okay? So it's a piece of the crust. It's a part of the outside of the circle. Okay? Now, there's two measures we have to be comfortable with. One of the measures is called arc measure. We've been dealing with arc measure the last couple of days. The arc measure is always in degrees. Okay? We've done a couple of assignments or problems based on this. So if you look at this example here of how we find the arc measure, if you recall, the arc measure would be equal to the central angle. So if we're looking for the measure of BC, so this is arc measure, then we would say that the arc measure of BC is 60 degrees. Okay? Notice that when we do this, our answer for arc measure is always in degrees. Okay? So now, when we talk about arc length, it's very similar, but it's a different measure altogether. Arc length, on the other hand, is the distance of B to C. So the distance of this arc. So we want to know not the degree measure of B to C, but we really want to know how long is BC. Okay, we want to know the distance, not the degree. So it's very important that we understand when we talk about arc length, we're talking about distance. When we talk about arc measure, we're talking about degrees. Okay? So these are the direct definitions. Okay? Just keep in mind, arc length will be measured in linear units, things such as feet, inches, yards, things that measure distance. Arc measure is always going to be measured in degree. Okay? So let's move on. Okay, so to find the arc length, we're going back to the P word that we did a while back ago. We're dealing with proportions again. So the key to finding arc length is to set up a proportion. Okay? And I'm going to show you, or as you can see on the notes already, the proportion we're going to set up is this proportion. Okay? And the way you think about it is we're setting up the part of the circle in degree wise equal to the part of the circle in length wise. For example, an entire circle all the way around the circle in degrees is 360. And on top of this fraction, because we need fractions for proportions, we're going to put the arc measure that we're trying to find the distance of. Okay? Then we're going to put it equal to another fraction where we're going to find the entire circumference, the entire distance around the circle, that's circumference. And on top, we're going to put the piece that we want. Okay? Once we set up this fraction here, we are then going to cross multiply, just like we did before, to solve. All right? So think of this guy as our formula to solving for arc length. We can use it to solve for circumference. We can use it to solve for arc measure. But the first couple of examples, we're going to try to solve for arc length. So the formula is arc measure divided by 360 equal to arc length divided by circumference. So part of the circle divided by the whole circle. Again, part of the circle divided by the whole circle. All right, so let's do example A. So it's important to understand that we need to fill in this formula. So our goal is to find the length, not the measure. So we're trying to find the distance between A and B. Okay, so to do that, we're going to do the formula of arc measure divided by 360 equal to arc length divided by the circumference of the circle. Okay, so what I want you to recall is we're going to start filling in the information that we need here. But before we put in arc measure and all this stuff, we have to remember that circumference is really the formula of 2 times pi times r. Okay, so in order to do circumference, we need to know the radius, and then we're going to multiply this stuff out. All right, so let's do it. So instead of circumference, we're going to use 2 pi r. So 2 times pi, and then if you look at my circle, my r is 12. It's the distance from the center to the end of the circle or edge of the circle. So r is equal to 12. So I'm going to plug in 12 here. All right. Now, that's going to give me, when I do the math, that's going to give me my circumference. Now I want to know the arc measure. And the arc I'm looking for is arc AB. But remember, your arc measure is the degrees. So instead of arc measure, the arc measure for AB, I'm going to put in the degree measure. So in this case, it's going to be 45 degrees. All right. The next thing I'm going to do is I want to put in the arc length. Well, here's the problem. That's what we're trying to solve for. So I'm solving for the arc length. So I'm going to call the arc length x because we don't know what it is. So instead of arc length, I'm going to replace it with a variable. Okay, so I'm going to do, before I cross multiply, before I do the cross multiplication, I want to clean up any math I can do. Okay, so I want to clean up circumference. All right, so let's do that math. Again, we're not going to multiply out the pi, so x is still on top. And if you remember, I'm just going to multiply the numbers here and leave it in exact format or pi form. Okay, so we're going to do 2 times 12, and that's going to give me 24 pi. And then this fraction over here, I always want to check, because I don't want to deal with big numbers, I want to check if I can reduce this. So as you look, this is reducible. So we're trying to figure out what number can divide the top that also could divide the bottom. And we're looking for the biggest number possible. Okay, so again, try to reduce this. If it doesn't reduce, it's okay. We can still do the problem by cross multiplying, but it makes it just a lot easier to reduce. So I know that this can be reduced by the top by 45 as well as the bottom. 45 divides the top and the bottom evenly. And if I do that, I get my new fraction of 1 over 8. Okay, so let me write this a little nicer. So now we have this proportion. 1/8 equal to x over 24 pi. And we can now cross multiply to solve. So I like to multiply with the x first. So we did 8 times x, and then we're going to multiply the 1 times 24 pi. So equal to 1 times 24 pi, which is 24 pi. Again, for now, just kind of ignore the pi. We'll deal with that later if we have to put it in decimal form. For now, we're just going to put it into exact form, and then we'll change it. So I want to solve for x, so I'm going to divide both sides by 8. Okay, so we're left with x equal to 24 over 8. Pi goes here. And then we could reduce 24 over 8. Okay? And that's going to give me x equal to, I can reduce by 8. That's going to give me 3 over 1, or just 3 pi. All right, so this answer is the arc length, and it's an exact. It's an exact answer. But if you look at the question here, it says, I want you to round to the nearest tenth. That means we actually have to multiply this out because it wants it in decimal form. So here's exact. So decimal form is going to be x equal to 3 times, and then we use the actual number for pi. All right, and if you do this correctly, you get 9.42, and this is my arc length in decimal form. So here's exact form if you're asked for exact form, and here is decimal form. All right, that's how you do example A. All right, let's try example B. I'm going to erase this because I need some room. Actually, I'm going to shrink it because I do need some room. So bear with me here. Okay, and now let's do example B. So we're going to set up the same proportion. We're trying to find the length of AB again. Okay, so we're going to go arc measure divided by 360 equal to arc length divided by circumference. And we know the circumference is the formula of 2 times pi times r. All right, so let's fill this information in. So the arc measure is always in degrees. So what's the arc measure of AB? It's given to you right here. It's 120. So let's fill that in. All right, and then the next thing I want to fill in is the circumference, which means I have to plug in r. So let's do that. So for circumference is going to be 2 times pi times, and then r, in this case, my radius is 3. Okay, and then arc length. Arc length is the distance I'm trying to find. I don't know it, so I'm going to call it x. So we'll put x in here. All right, and now let's start cleaning this up. I want to clean up my circumference first. I'm not going to multiply out pi. So it's equal to x over 6 pi, because 2 times 3. And now we're going to reduce 120 divided by 360, if at all possible. So we want to reduce as low as possible if we can. So we actually can reduce by 120. 120 can divide both the top and bottom. So let's reduce by 120, and then we get our reduced fraction of 1 over 3. Now we have this simple proportion, so we're going to cross multiply. So I do the x's first, so x and 3, or 3 times x, that gives me 3x, and then we're going to do 1 times 6 pi, that's going to give me equal to 6 pi. And last but not least, let's just solve for x. So I'm going to divide both sides by 3. Remember, we're trying to just kind of ignore the pi for now, we'll deal with that later. And x is going to equal 2 pi. So again, this is our exact answer, but check, do we want exact answer or do we want nearest tenth again? So if you look, we want nearest tenth. So that means I want decimal form, and we're going to do x equal to 2 times 3.14 and throw that into our calculator. And we get x equal to 6.28. And I forgot in the last example, but I'll do it here. We want to round to the nearest tenth. So we want, our cutoff is the 2, but we look at the 100th spot. Is the spot after the 2 bigger than 5? Because it is, that means the 2 will round up to 3. So our correct final rounded answer would be 6.3. All right. Let's do one more example. Let me just shrink my work here. All right, let's do C. So again, we're trying to find the arc length of AB. So we're going to plug in 2 fractions. Let's see if we remember the formulas. Okay, so again, just use this as a reference. Our arc measure goes on top. So our arc measure is from A to B in degrees. That's going to be 67 degrees. And then we want the whole degrees of a circle. That's 360. That goes on the bottom. Okay, and now we want the arc length, which we don't know, so we're going to use that as x. That's what we're trying to find. And then we want the length of the entire circle, which will be given to us by this formula. 2 times pi times r. Okay, but my r is from the center to the edge. So what our r is really 5, because 10 is the diameter, but we want the r. So it's going to be times 5. All right, so let's clean this up as best we can. I like to do the circumference part first. So 2 times 5, that gives me 10 pi. And 67 over 360, right off the top of my head, I can't think of anything that will reduce that, so we have to leave it like that, okay? Which is okay, we're just going to cross multiply and have some big numbers. So let's cross multiply here, 360 times x. And then we're going to have 67 times 10. And then pi comes along for the ride. And now I want to go ahead and I want to solve for x. So I'm going to divide both sides by 360. So x equals that. Okay, we can reduce the fraction to get the exact answer if you like. Like for example, I could reduce by 10, it would be 67 over 36 pi. But remember the directions. In this case, we really don't want the exact. It keeps telling us we want the nearest tenth. So what I'm going to do is I'm going to divide 670 divided by 360 and then times it by pi. All right, so we're going to go x equals, and let's do this division here. 670 divided by 360. Okay, we get approximately 1.86, and then bring down the pi. And now we have to multiply out the pi to turn it into decimal form. So 1.86 times 3.14. So let's multiply that out, and we'll get our final answer. If we put what we have in our calculator, we get 5.84. But rounding to the nearest tenth, like the question asked us to do, it should be 5.8. Okay, and that is how we find arc length. Remember, set up a proportion using this formula. It's pretty much part of the circle in degrees divided by the whole circle in degrees, and then part of the circle in length divided by the whole circle in length. And you could get your arc length.